All right, welcome back. So at this point, you should have ran your three models and maybe even your preliminary correlations. If not, make sure you get those at some point um, so that you are ready for part two here of the analysis, where we're going to talk about how you pick your best model and then how you write it up. So what you did in part one, you used SPSS regression to do the following types of multiple regression analyses: a simultaneous, otherwise known as enter, stepwise, and a backward model. You predicted students' authoritarianism scores, that was your DV, from the following potential predictors: authorita, acceptance of others, religiosity, homophobia, and sex. So four predictors. So, which model is the best? Which one do you think is the best to predict authoritarianism? And how did you fill in this table? So, hopefully, you did that. This is the table that's on your homework assignment. Hopefully, you filled it in and you posted which model you thought was the best. So, let's go through the criteria and do this together. And so, criteria one, again, is sort of the most straightforward. Highest R squared, the most variability predicted. That's one way to say this is the best model. So there's your rule: higher R squared, better model, more variability predicted. So there's enter. We predicted 57% of the variability. That's crazy. There's our stepwise. It had two steps, and at the second step, it took out a couple variables. We ended up with just acceptance of others and homophobia, and it predicted 49.3% of the variability. How about backwards? So backwards, again, just throws everything in and takes out the junk. At the end, it only had two steps, right? So it threw everything in. Second step, it took one thing out. The one thing that it took out, we still have sex, religiosity, and acceptance of others. We accounted for 53% of the variability. So if you sort of order them, you'd say, well, enter was the best, and hint, enter's always the highest R squared. More predictors never leads to worse R squared. Then stepwise at about 49%, and finally we had our backwards model there at 53%. All right, how about parsimony? All right, did I do it again? Parsimony? I did it. Parsimony. Simple. That is, fewer predictors is good. So if it doesn't go along, so fewer predictors, as long as you don't lose a huge chunk of your R squared, is good. So looking at it one at a time, the enter model had all four predictors in there, right? So it's the worst for parsimony. Stepwise ended up with just two predictors in there. That's pretty darn parsimonious. And then finally, backwards had three. So sex, religiosity, and acceptance of others. So in terms of number of predictors, stepwise was the best. Backward was the second best with three. And enter was the worst. Again, it always is. So finally, we have criteria number three. That is practicality. Are some of these things more of a pain in the butt to collect or more challenging to collect than others? I don't know. Let's see. So a model, the rule is that a model with fewer difficult or expensive or whatever it is, pain in the butt predictors might be a better model to choose. So there's enter. Enter's got everything. So again, it's the worst. Stepwise has acceptance of others and homophobia. So two. So practically, there's only two things you gotta get. But homophobia might be one that's a little tough to collect with some populations, or you might think people are gonna lie. Your backwards ended up with sex. That's super easy. Religiosity. That one might be a little touchy, right? People don't like to talk about their religiosity. Acceptance of others. Probably not too bad. So I think the two ones here that you got to sort of weigh are homophobia and religiosity as ones that might be sketchy. People lie, they don't want to fill it out, whatever it happens to be. So I would say backwards, from my experience, is probably easier to get religiosity than homophobia. So to me, sex is so easy to get as a predictor. God, that sounded bad. That it doesn't. It's not even really like you got to do anything to get it, right? It's super easy. Check the box here. So really, it's a battle between religiosity and acceptance or homophobia and acceptance. And I would say for the little bump here in R squared that we get, right? We get about 4 percentage points more, 0.53. I would rather collect religiosity than homophobia. So here's my argument. Homophobia seems like the hardest variable to accurately capture. So I liked backwards. I thought it was more practical than the other two, and enter always loses. So which model is the best? Let's fill out our table. This is what I wrote. So in terms of R squared, enter. In terms of parsimony, that would be stepwise. And in terms of ease of getting those predictors, I think backwards was the easiest. So which model? Enters the highest R squared for predictors. Stepwise, it had the lowest R squared based on 2 predictors. Still not awful. And backwards was like, Goldilocks. It was sort of in there. Good R squared. Only 3 predictors, one of which is super easy to get. And I don't have to bother dealing with people complaining about taking the homophobia or lying on my scale. Yeah, I picked backwards. So backwards seemed the best because it has a higher R squared than stepwise, and it requires fewer variables than enter, right? So it's more parsimonious, but in particular because it does not require measurement of homophobia, which could be difficult to collect accurately. People are going to lie. Social desirability. I think backwards is the best. So you do not have to agree with me, and that is totally okay. So there is a wrong answer, but there's 2 potential right answers here, right? So enter is wrong. Let me just help you. So if you liked stepwise, as long as you can argue it, because you do have to argue why you chose your model, both on Canvas and also in your APA write-up, as long as you can argue using the criteria for why you picked your model, I'm cool. Just write it up. So if you like stepwise, good, but enter is not the best model. So now what? Choose the model of the 3, really the 2, that you think's the best. You will write that model up in an APA results section. There is an example to help you do this that you can type over and whatnot. So note that different students may have different best models. So when if you do compare your results to other students, make sure you're comparing the same model. So for the model that you consider the best of the 3, tell me which variables are the best predictors of authoritarianism. So you can use betas, or you can use squared semi-partial correlations for that. I want you to describe which variables are in the model that you use in your APA write-up. Tell me the relative importance of each predictor. And again, 2 ways to do that. You can compare the beta coefficients, and the one with the biggest beta, absolute value, is most important. The one with the next biggest beta is next most important, etc. And then I also want you to determine the unique contribution of each predictor. So you're going to square those part correlations to get this squared semi-partial correlations, and they tell you what proportion of variability in authoritarianism does this particular predictor uniquely predict. So it's another way to say, yeah, this is a really important predictor. So compare those semi-squared partial correlations among the predictors in the model. And you'll see how that fits into the APA write-up. So let's do the beta way of picking which predictors you think are the most important. Again, higher beta in absolute value indicates that that particular predictor is more important for your model. So backwards is the one I picked. Always go to the last step. Okay, don't forget that. Don't go to step 1. Go to the last step. There's my 3 predictors. We got constant, just kind of always in there. Acceptance of others, religiosity, and sex. If we look at our betas, the absolute value, so ignore that negative sign, clearly acceptance of others is the most important predictor of authoritarianism. It has the biggest beta at 0.554. That is followed by religiosity and finally sex. So acceptance, religiosity comes in second, and sex is the least important at 0.277. So how about in terms of unique variability that each one predicts? What's the most important variables in your model? So we're going to square our part correlations to get squared semi-partial correlations, and it's going to tell us which predictor accounts for the most unique variability. And what that means is only that predictor accounts for that variability. That's why you want that predictor in your model. That's why it's important for the model, because the other ones don't have like overlap where they could pick up some of it. So there's my model again. I go to step 2. Parts are on the far right. There they are. We're going to square those, and you gotta use your phone or whatever to do it. And when you square them, you get 0.29, 0.10, and 0.07. And it's literally just the thing times itself, okay? So 0.29 means that about 29, scooch the decimal over twice, 29% of the variability in authoritarianism is predicted by acceptance of others alone, right? A big chunk, more than the other two combined. Next most important is 10%, 0.10, which is religiosity. And finally, sex comes in third at about 7% of the variability in authoritarianism. So there's an APA regression summary table you have to complete. So I want to show you where the stuff for that comes from, because it is a little confusing. There's my backwards model with my squared part correlations. Again, always go to the last step. There's Barfine Rainbow Nessie. This table is in your APA write-up. If you do the stepwise approach, you do want to have that R-squared change column in there. It's in the table, so it's not hard to do. But note, if you do the backwards, you do not have to have it. So there. But you can if you want. It would be R-squared change. It's what's taken out at each step. So where does stuff come from? Well, B's come from the column called B up in your SPSS output. You ready for this? It's going to be shocking. Betas come from the beta column. And note the little stars on each of those. They are all statistically significant. And you can tell that by looking at the sig column, and everything here is less than 0.05, so it gets a little star as noted below the table. The zero order is just normal Pearson correlation. That's all these are. So if you look at the original correlations you did, you'll see that these are just the correlations of each variable with the predictors. So note I put sex first, then religiosity, or acceptance of others, and finally religiosity. And then your squared semi-partial correlations are RSP2, and those just come from your little hand calculations. So if you choose stepwise, you will need that R-squared change column. Okay, just to let you know, I'm pretty sure it's in the write-up. So you do have to include that ANOVA that was part of the regression output, and it goes in a little sentence that says overall, the model significantly predicted variability in authoritarianism, comma, F to whatever degrees of freedom. So again, always go to the last step, and sig is less than 0.05 for the model that had those three predictors, sex, religiosity, and acceptance of others. That would be how we write it up. It's an F of 3 and 29 degrees of freedom is equal to 10.93. P was less than 0.05. And this just shows you where everything comes from. So this goes into the text. Again, you'll see it when you get there when you're doing your write-up. So for the APA write-up, you will need descriptive statistics for the DV and all IVs. And note that one of your independent variables, sex, is not continuous. So you would not use the mean. You want to make sure you run a frequency of sex, because you will need it for your table. So you need means and standard deviations for continuous variables. So that's basically everything but sex. And then frequencies and percentages for your nominal variable, which is sex. That's your predictor. You will also need a correlation matrix of all predictors and DV with the DV from the correlations procedure. Do not use the ones that come out of the regression procedure, because you need two-tailed SIGs, not one-tailed. And a word of advice, make sure to just sort of look through the APA write-up template that I give you before you attempt to write up your analysis, so you don't accidentally leave something out and have to go back in and run a bunch of stuff. So have fun. Hit me up with any questions on the discussion, and I'm interested to see which models you picked.